Good morning everyone. This is Lalit Narayan Mato and I am going to teach Power Plant Engineering for the BTech 7th semester Mechanical Engineering student. Okay, so previous class we have discussed boiling water reactor, pressurized water reactor and Candu reactor.
Okay, sir.
Okay, so all we have discussed the working principle of pressurized water reactor, Candu reactor and boiling water reactors. So today we will see some video related with the pressurized water reactor and Candu reactor.
We discuss about the which type of the fuel and the which type of the reactors and which types of the moderator is used in a PWR. PWR means pressurized water reactors. In a PWR, highly enriched uranium is used as a fuel. Okay, and the reactor is heterogeneous. Heterogeneous reactor means the fuel rod is surroundings by the moderator. It is called as the heterogeneous reactors. Okay, and this uranium is clad uranium. Okay, and ordinary water under high pressure is used as a moderator, coolant and reflector. Means ordinary water is used for moderators, coolant as well as for the reflectors. Now here you see this is the diagrams of the pressurized water reactors or a arrangement of pressurized water reactor in these diagrams. Okay, So these PWR reactors are divided into two circuits. One is called as the primary circuit. So here in this rectangle, you see it is called as the primary circuit. And this part is called as the secondary circuits. Okay. And in this primary circuit, what are the components is there? First one is this reactor. These are the pressurizers, and this is the heat exchanger and this coolant pump. This is the secondary circuit, that is the steam turbine, condenser, pump, and these heat exchangers. Why its name is given the pressurized? Because this pressurizer is used in this primary circuit. That's why its name is given the pressurized water reactors. Now, what is the functions and what is the constructions of these pressurizers? The pressurizing tank include in the circuit to maintain the constant pressure in the circuit throughout the load range. Means the function of this pressurizer is to maintain the constant pressure in these primary circuits. Okay, so this is the pressurizers, and this pressurizer is consist of this heater and the vessel. Means this outer part is called as the vessel. The pressurizer is simply a pressure vessel with a heater at the bottom and the water is sprayed at the top. Means at the bottom of this pressurizer, here you see one electric heater is put it, and from the top the water is sprayed. So this is the construction of this pressurizer or a pressurizing tank. The water in the pressurizer is boiled and converted into the steam by electric heating coils before starting the reactors. Means before starting the reactors, we need to start this heater, and this heater is boil the waters, and this boiled water is create the certain pressures in the primary circuit. So these result in an increase in the pressure. Means when we start these pressurizers, they increase the pressure in the primary circuits. If the primary circuit pressure become too high, means it is not necessary, it is only increase the pressure. Sometimes the pressure is increased too high, then we need to reduce the pressures. Okay, so how we are reduce the pressure? So at that time we can spray the cold water. So cold water is spray into the steam. So here you see in the upper parts of these pressurizers, the water spray is provided. Okay, so water is supplied and water is sprayed into the steam. So when we spray the water into the steam, what happens? They condense the steam. Means the steam is converted into the water. It is called as the condensed steam, and reduce the pressure in the primary circuit. Means this pressurizer is used to increase the pressures or reduce the pressures. Okay. Now we understand its construction. Now we understand the working of this PWR. So water in the primary circuit get heated by absorbing the fission energy in the reactor core. So here you see this is the reactors, and in the reactor the fission process is carried out, and due to this fission process the heat energy is released. So this heat energy is absorbed by this coolant. Okay, so here you see this coolant is enter into this reactor, and in this PWR we are use the ordinary water as a coolant. Means the water is enter here. Okay, and this water is absorbed this heat energy, and this water is coming out. Okay, why here water is coming out? We are not mention here the steam is out. We just mention this coolant is out because here the pressure is too high. That is a 130 bar to 150 bar pressure are there. Okay, so here only in the primary circuit this water is circulate, no steam is there. Okay, then after this water coming out from this reactor is supplied into these heat exchangers. Okay, and these heat exchangers, this water of the primary circuit is supplied heat energy to this water of the secondary circuit. Here you see this is a heat exchanger are there. Means heat is exchanged between the two medium. One medium is the water in the primary circuit, and second medium is the feed water in the secondary circuits. Okay, so this feed water is converted into the steam here. Okay, and in this primary circuit temperature of the water is reduced, then it is supplied to this coolant pump, and then again supplied to these reactors. So in order to prevent the boiling of water in the reactor core, it is kept under a pressure of about 130 to 150 bar. Means this coolant supply to this reactor with a pressure of 130 to 150 bars. Okay, so they are in a water state, and this water is coming out from this coolant and it is supplied to heat exchangers. So it help in absorbing the heat by water in a liquid state in the reactor. Means due to these high pressures, means this high pressure is help to absorb the heat energy into liquid state. It is not converted into vapor state because at the 130 or 150 bar, the boiling temperature of the water is increased. Okay, at the atmosphere pressures, the boiling point of the water is 100 degree. But here pressure is higher. That means boiling point temperature is also higher. Means its temperature are above the 200 degree centigrades. The steam produced in the secondary circuit is used in a conventional way in a steam power plant cycle as shown in this figure. So here steam is generated in the secondary circuit in these heat exchangers. Okay, and then after circuit is same as the conventional steam power plant, means the as a rank.
Okay, Abhishek Kumar. No answer.
Rankine cycles. Okay, so in a Rankine cycle, after the boiler or a steam generated by the boiler, it is supplied to turbines. Okay, so here steam is coming out from this reactor, means this is the component used instance of this boiler. Okay, these reactors, pressurizer, heat exchangers. So this steam is supplied to this steam turbine. In a steam turbine, isentropic expansion process is carried out. Some work is produced by the steam turbines. This generator is runs by the steam turbine and electricity is produced. Then the steam coming out from the turbine is supplied to these condensers. In this condenser, the steam is converted into the water, and then it is supplied to feed water pump, and then again supplied to this heat exchanger. This way the cycle is continuously run. The water coolant from the heat exchanger is recirculated to the reactor with the help of this coolant pump that we already discussed. In this reactor, the water flowing through the reactors become radioactive. Means water flowing through the reactor means from this part. Okay, the waters are radioactive. Therefore, this primary circuit must be heavily shielded to protect the operator. Means this we need to only seal to this primary portion. Shielding of the secondary circuit is not required because here that is a indirect heat transfer takes place. So only primary circuit are shielded. Okay. Now by radiation, inspection and maintenance of the turbine, condenser and the feed pump is possible. Okay, so steam is produced in the secondary circuit. Okay, steam is not produced in the primary circuits. Okay, so inspections of the secondary circuit is easy, means the inspection, either the maintenance of the turbine, condenser and the feed pump is possible because they are the radiation free parts. Small number of control rods are required, means in the reactor the controller requirement is the small. Greater energy is extracted per unit weight of fuel loaded, means with compared to the fuel we can extract the great energy, means from the small quantity of the fuel we are extracting the great energy. Okay, so this is also the meaning of the high power density, means from the smaller fuels we can extract the more energy. Now last topic is the disadvantages. First disadvantage, its capital cost is high due to heavy and strong pressure vessel is required in the primary circuits. Okay, so in a primary circuit the pressure is high, that is a 130 to 150 bar. Okay, and we are need to completely seal the primary circuit because it's the radioactive parts. That's why the capital cost is increased. The thermodynamic efficiency of this plant is as low as 20% due to low pressure in the secondary circuit. So in the secondary circuit the pressure is low, and due to that thermodynamic efficiency of the plant is low as 20%. It's require enriched uranium fuel, so cost of enriched uranium is high. Okay, so in a pressurized water reactor we are not use the natural uraniums. Okay, that we already discussed in the first point. We need to use the enriched uraniums, and the cost of the enriched uranium is high. It is necessary to shut down the reactor for a fuel chargings. Fuel charging means when we need to put the new uraniums. Okay, at that time we need to stop the reactors. Okay, the corrosion problem are more severe as the corrosion is accelerated in the presence of high pressures and high temperature water. So in a primary circuits the pressure of the water is high. Okay, so they are lead to the corrosion problems.
Okay, Abhishek Kumar.
Yes, sir.
So how pressurized water reactor differ with the Rankine cycle? कुछ भी आंसर कुछ भी anyone?
No, sir.
No.
वाट ये प्रेशराइज वाटर इसमें सर रिएक्टर का यूज होता है और एनकाइन साइकिल में बॉयलर का यूज होता है सर।
हाँ, सो बेसिकली प्रेशराइज वाटर रिएक्शन में आप देख रहे हो यहाँ पे दो सर्किट है, वन इज द प्राइमरी सर्किट, अनदर इज द सेकेंडरी सर्किट। तो सेकेंडरी जो सर्किट है वो आपको एज सिमिलर एज कंपेयर टू रैंकिन साइकिल आपको दिख रहा है, बट इन ए प्राइमरी साइकिल बेसिकली यहाँ हम लोग क्या करें, न्यूक्लियर एनर्जी। तो यहाँ पे क्या, जैसे कि टर्म है प्रेशराइज वाटर रिएक्टर। ओके, सो हम लोग क्या करें यहाँ पे कूलेंट, नॉट ए जस्ट स्टीम, कूलेंट को हम लोग पास करें इस हाई रिएक्टर से in a high pressure or and a high energy, and this high energy is transferred to this feed water. That means transfer of energy taken place from this heat exchanger, and this feed water is converted into steam in this secondary circuit, and this steam is utilized for steam generator. So basically there is a two circuit, primary circuit where coolant is exchange heat to the steam, and this steam is utilized for electricity generation.
हेलो सर।
हाँ
सर तो इसको कपलिंग जैसा ट्रीट कर सकते हैं सर?
कपलिंग मीन्स वेयर मोशन इज ट्रांसफर्ड। ओके, कपलिंग का कहने का मतलब है जैसे कि वहां पे क्या होता है, मोशन इज ट्रांसफर, बट यहाँ पे क्या हो रहा है, ट्रांसफर ऑफ एनर्जी, मतलब हीट एक्सचेंजर है यहाँ। कपलिंग थोड़ा कहना सही नहीं होगा, दैट मीन्स कपलिंग कहने का मतलब है कि मोशन का ट्रांसफर हो रहा है फ्रॉम वन शाफ्ट टू अदर शाफ्ट। सो बेसिकली यहाँ पे क्या कहते हैं, कूलेंट जो रहता है वो प्रेशराइज में रहता है। ओके, दैट मीन्स कूलेंट इज जस्ट पास थ्रू दिस रिएक्टर इन ए प्रेशराइज वे, and due to high sufficient of energy, this coolant is transfer their energy to this steam, that means feed water, and if this feed water convert into this steam, and this steam is used for electricity generation. This is the basic principle of pressurized water reactor. तो जो हम लोग नेक्स्ट अब डिस्कस करने वाले हैं वो है कैंडू रिएक्टर। ठीक है, बेसिकली दिस इज डेवलप्ड बाय द कैनेडियन, दैट्स व्हाई इट इज कॉल्ड कैंडू रिएक्टर।
In this video, I explain first 3-digit is indicate Canadians, 4-digit is D. D is given as the Canadian deuterium uraniums. So deuterium is used as a
ओके, सो बेसिकली कैंडू का कहने का मतलब है इसी डेवलप बाय कनाडा, दैट्स व्हाई इट्स कॉल्ड कैनेडियन, एंड ड्यूटेरियम दैट मींस हैवी वाटर, दैट इज द मॉडरेटर, as a moderator is used deuterium, that means heavy water, that is called deuterium, and we fuel use uranium, that is called uranium. So basically Candu का मतलब क्या है, Canadian deuterium uranium.
moderators, and this uranium is used as a fuels. Okay, so these names are combination of the three terms. First term is indicate the development of country, second word is used as the moderators, and the third word is indicate the fuel used in a reactors. It use pressurized heavy water, PHW means deuterium oxides. Deuterium oxide is also written as the D2O as a moderators. Okay, so this deuterium oxide is used as a moderators. as well as the coolant, means moderator and coolant material are same. Why? The fuel uses natural uraniums. So fuel is uses natural uraniums. These reactors are more economical to those nations which do not produce enriched uranium, as the enrichment of the uranium is very costly. Okay, means it is the benefit for the country which are not able to create enriched uraniums. Okay, so they can use the natural uranium as a fuels in a Candu reactors. The arrangement of the different components of the Candu type reactor is shown in these figures. Okay, so here you see these are the diagrams of the Candu reactors. Okay, so suppose we starting from the center parts. So it is the core. Okay, in a core you see this is the pressurized fuel tubes are there. Okay, so this is the one pressurized fuel tubes, this is the second pressurized fuel tubes. In these pressurized fuel tubes the fuels are put at. Okay, that's why its name is given pressurized fuel tubes. In a pressurized fuel tubes there is a number of bundles are there, and in these bundles there is a number of pellets are provided that we discuss later on. Okay, so this pressurized fuel tube is create the heat energy due to the fission of the uranium materials. Okay, and this heat energy is carried by this heavy water circulating in this pipe, means here you see heavy water is supplied in this core, they absorb the heat energy and this transfer heat energy to the heat exchangers. Okay, so in these heat exchangers here this heavy water is circulating, means D2A is circulating. This D2O is supplied heat energy to the water that is passed from these other pipes in these heat exchangers. Okay, and again this heavy water is coming and it is again passed from these pressurized fuel tubes. So this heavy water is again absorb the heat energy and then it is supplied to these second heat exchangers. So here they are also supply heat energy to the water and the water is converted into the steams. Okay, so this is the basic functions of these pressurized tubes. Okay, and this is the steam collector. So here steam is collected, then the steam is supplied in high pressure turbine, then it is supplied in low pressure turbine, then condensers and feed water pump, and again feed water pump is supplied in these heat exchangers. Okay, so in this heat exchanger here you see from the one sides this feed water is supplied and this feed water is converted into the steam, and from the pipe heavy water is supplied. So heavy water supplied heat energy to these feed waters and feed water is converted into steam and the steam is supplied to this turbine. So in this reactor the fuel is normal uranium oxide as a small cylinder pellets. Okay, means the uranium fuel is converted into the small cylinder pellets. Now what is the size of the cylinder pellets? So the pellet are packed in a corrosion resistant zirconium alloy tubes and its size is nearly 0.5 centimeter long, means its length is 0.5 centimeters and 1.3 centimeter diameters to form a fuel rods. Okay, so what is the size of fuel rod? That is a 0.5 centimeter long and 1.3 centimeters diameter. The relatively short rods are combined in a bundle of 37 rods. Okay, so when we combine the 37 rods, okay, so it is called as the one bundles, and that is how 12 bundles are placed end to end in each pressurized tubes. Okay, means here you see in this diagram two pressurized tube is there. In a one pressurized tube there is a 12 bundles are there. In a 12 bundle 37 rods are there. Okay, so total how many rods are there in a one pressurized fuel tubes? That is a 37 into 12 fuel rods are there. Okay, and the size of this one fuel rod is the 0.7 centimeter long and 1.3 centimeters diameter. The total mass of fuel in the core is about 97,000 kilojoules. Okay, so that is the number of fuel tubes are there. Okay, so total weight of the fuel is 97,000. So in a Candu reactors we are able to refuel the core in a operating condition, means we not need to stop the reactor for the refilling of a fuel. The coolant heavy water is passed through the fuel pressure tubes and then after in heat exchangers. Okay, so here you see these heavy waters are continuously recirculated in these circuits. Okay, and this heavy water is passed from the core, and in the core they absorb the heat energy, and this absorbed heat energy is supplied to the water in a heat exchanger. So in a heat exchanger there is a two mediums are there. One medium is the heavy water and the second medium is the feed waters. Okay, so this heavy water is supplied heat energy to the feed waters, and feed water is converted into the steam. The heavy water is circulated in the primary circuit in the same way as with the PWR, and the steam is rise in the secondary circuits and transferring the heat in the heat exchangers to the ordinary waters. Okay, so this part is called as the primary circuits. Okay, so in a primary circuit these cores are there. In a core, pressurized fuel tubes are there, circulating pumps are there, and these heat exchangers are considered in this primary circuit, and this part is called as the secondary circuits. Okay, so in this heat exchanger the steam is produced, and this steam is supplied in these steam collectors, and then after it is supplied into this high pressure turbine, then after it is supplied in the low pressure turbine. So in this turbine this mechanical work is produced. This mechanical work is supplied to generators, and generator is produce the electricity. Then after steam coming out from the low pressure turbine is supplied to these condensers. In the condenser it is condensed, means the steam is converted into the water, and this feed water is again supplied to these heat exchangers. Okay, so this way this cycle is continuously run. The control of the reactor is achieved by changing the level of moderator in the reactors. Okay, so as a moderator we use the D2O. Okay, so if we change the level of the moderators in these reactors, means changing the level of the moderator means changing the level of D2O in this core, then what happen, we are able to control the reactions in the reactors. Therefore the control rod are not required. So in a Candu reactors control rod are not used. Cadmium rods are used to start and shut down the reactors. Okay, so in earlier cases what we studied, the control rod are used to start the fission reaction, control the fission reaction, and stop the fission reactions. Okay, but in these Candu reactors we are not use the control rod. Okay, so by changing the level of moderators we are control the reaction, but how we start and stop the chain reactions? So for starting and stopping of the chain reactions we need to use the cadmium rods in a Candu reactors. Now before the low pressure compared with PWR and BWRs, means reactor vessels are not required to sustain heavy pressure, so we are able to make it the light. Only the fuel tubes are designed to withstand the high pressure, therefore the cost of the vessel is less. Heavy water is used as a moderators which has higher multiplication factors and low fuel consumptions. Fourth is less time is needed to construct the reactors compared to the other reactors. Now disadvantages of Candu reactor. First, the cost of heavy water is very high, so we use the heavy water as a moderators as well as the coolant, so its cost is high. It requires high standard of design, manufacturing, and the maintenance. So it's required a higher standard of designs, manufacturing, as well as the maintenance. The power density is considerably low compared with the PWR and BWR, therefore the reactor size is extremely large. And the last disadvantage, the leakage is the major problem, as there are two mechanically shielded closures per fuel channels. Passengers, here this.
ओके, सो बेसिकली जितने भी रिएक्टर है सब में आपको डिफरेंस क्या मिल रहा है? कंस्ट्रक्शन, वर्किंग प्रिंसिपल सभी का सेम है, ठीक है, लेकिन थोड़ा सा आपको डिफरेंस क्या है जो वो कंस्ट्रक्शन. सो आपको कंस्ट्रक्शन याद रखना है, बाकी सेकेंडरी सर्किट आपको सेम मिलेगा, जस्ट डिफर क्या है प्राइमरी सर्किट में, हाउ द स्टीम इज जनरेटेड. ओके, तो घर पे आप लोग का ये होमवर्क रहा, स्टडी करना है कैंडू रिएक्टर, BWR, PWR and Candu reactor. ओके, सो नेक्स्ट क्लास हम लोग कुछ और रिएक्टर देखेंगे एंड डिसएडवांटेज है ना एडवांटेज।